Hello and welcome to Kumant Online Academy. In today's lesson, we want to continue with our discussion on motion, and we are going to be looking at the equations of motion. In our last lesson, we talked about acceleration, velocity, and speed. Today, we are going to be looking at equations that we can apply to find any of the parameters we are looking for in motion. We have three basic equations that we actually use in motion, and we apply each of them in different formats depending on the condition of the moving body. We apply a different format when the body is accelerating and another format when the body is decelerating. That is a different format when the body is increasing its speed and another format when the body is reducing its speed. Increasing of speed gives acceleration, and decreasing the speed leads to deceleration or retardation. Now the equations are just the same, only the signs are different, as you can see shortly. Now for the acceleration, the equations are: number one, v is equal to u plus at. That is the first equation. The second equation is v squared is equal to u squared plus 2as. And the third equation is s is equal to ut plus half at squared. Now we know that we represent final velocity with u, initial velocity is u, final velocity as v, initial velocity as u, then a is acceleration, t is time, and we use s to represent distance when we are considering motion. You shouldn't get confused over this. Never you use s to represent speed. Both speed and velocity are represented with v. Now, when the body is slowing down or decelerating, we use this format. We just change the positive in the equations to negative. So instead of having u plus at, that v is equal to u plus at, we now have that v is equal to u minus at. So here also we change it, and here also we change it. All the positive sign, we change them to negative. Then all the parameters still remain the same. V still mean final velocity, u still mean initial velocity, a still mean acceleration, t time, and s distance covered. Now, how do we know which of the equations to use? When you are given any question, what you have to look for is this: when distance is not involved in the equation given to you, you use this equation. This one does not contain s. That means it does not contain any distance. Now, when time is not involved, you look for the equation that does not contain t. That is this one. There's no t in this equation. And when final velocity is not involved, you look for the one that does not contain final velocity. There's only one that does not contain final velocity, and that is this one. You use it. Now, sometimes you may need to use one of these equations, the first equation, to get one of the parameters that you use now to find the other parameters you are looking for. Don't worry, from the examples we are going to solve now, you understand what I mean by this. Now look at this example. A body starting from rest travels for 30 seconds. Determine the final velocity attained after covering a distance of 40 meters. Now, whenever we hear that a body starts from rest, it means that its initial velocity is equal to 0. So without being told that the initial velocity is 0, once you hear that the body starts from rest, you should just know it that the initial velocity is equal to 0. So write u is equal to 0. So here, because we are told that the body starts from rest, we take it that our initial velocity is equal to 0. Now we write down other parameters given. Bringing out the parameters will help you to know which of them is missing so that you can now determine which of the equations to use. Now u is equal to 0, t is equal to 30, s is equal to 40 meters, and then we are looking for the final velocity. We are asked to determine the final velocity. Now here, how do we know which of the equations to use? All the equations that are given, all of them contain acceleration, but in these parameters we have here, there's no acceleration in the parameters. There's no acceleration given to us. Equation 1 contains acceleration v equal to u plus at. A is acceleration. Equation 2, v square is equal to u square plus 2as. It contains acceleration. Equation 3, s equal to ut plus half at squared. It also contains acceleration. So there is a problem. We have to now look for the acceleration that is not given. So we have to use any of the equations that contains the parameters, that we can use any of the parameters given, any of the parameters we already know, to get the acceleration from it. Now, we don't know final velocity, so that means that we shouldn't consider any of the equations that contains final velocity. So now this means that we are going to use the equation that contains initial velocity, time, and s, of course, and then acceleration. Anyone that contains final velocity, we cannot use it, because if we put final velocity there, we will have two unknowns. We cannot be looking for two things in one equation. We can't solve it. So in these equations now, which of them does not contain final velocity v? There is only one, which is s is equal to ut plus half at squared. So we use it to find acceleration. We already know our u, which is initial velocity. We know our u, initial velocity. We know our s, distance. We know our time. So we can now look for the acceleration. So that is the next thing we are going to do. So we use s equal to ut plus half at squared. If we put all the parameters given, 40, which is distance, is equal to u, which is 0, times t, which is 30, plus half a times t, which is 30 squared. If we solve this, we are going to get that a, or acceleration, is equal to 0.089. Now that we now have the acceleration, we can put it in any of the equations that contains final velocity. Both equation 1 and equation 2, both of them contain final velocity, so we can use any of them. If we use equation 1, we know initial velocity, we know acceleration, and we know time. If we use equation 2, we know initial velocity, we know acceleration, and we know distance. So any of them that we use, we are still going to get the same answer. So let's use equation 1. Equation 1 looks simpler, so let's use it and solve it. Now, v equal to u plus at. U is equal to initial velocity, which is 0, plus a, which is 0.089, then times by time, which is 30. If you solve this, we get 2.67 meters per second. That is the answer. Now let's try and use the second equation to solve it, which is v squared is equal to u squared plus 2as. Now, v squared is equal to initial velocity is 0, 0 squared plus 2 times acceleration is 0.089 times by 40. Distance is 40. So 0 squared is equal to 0. This is equal to 0 plus 2 times 0.089 times by 40. This will give us 7.12. 7.12. So v squared is equal to 0 plus 7.12 is equal to 7.12. So v is equal to root of 7.12. This will give us 2.67 meter per second. So the answer remains the same. So each of the equations, any of the equations that we use that contains final velocity, we can use it to get the same answer. So this is how to use or how to apply the equations of motion. Now let's have some assignments. Okay, the assignment number 1. A car accelerates from 0.54 km per hour to 0.72 kilometer per hour in 10 seconds. It is accelerating, it is increasing. Now find its acceleration. It increases its velocity from 0.74 kilometer per hour to 0.72 kilometer per hour in 10 seconds. Find its acceleration. Then 2, a man increases his speed by 5 meter per second after 30 seconds. If his initial velocity is 20 meter per second, calculate the distance covered. Now here, look at this question now. A man increases his speed by 5 meter per second after 30 seconds. That means that he added 5 meter per second to the initial velocity he was traveling with. He was traveling with 20 meter per second. Now he added 5 meter per second to it. So what will be the final velocity now? You get it, and then you look for other parameters and solve. Thank you.